The three-stroke internal combustion engine works in a cycle that comprises expansion, compression, and detention. In an oscillating piston engine, the piston stops for an instant. In the three-stroke engine, we control the stop time of the piston. The three-stroke engine has a piston hydraulic pump driven by fuel explosions. This pump delivers pulses of hydraulic oil. To stop the piston in the three-stroke engine, we stop the piston pump by means of a block valve in the oil circuit. By closing the block valve that allows the oil to escape from the pump, we stop the piston and thus we have a three-stroke engine. When the piston is stopped, the valve's opening and closing cycle to take place. In a four-stroke engine, this cycle occupies 2 strokes. For intake and exhaust there are several alternatives, including using a valve in the piston head. What we have so far is a 3-stroke engine that shoots jets of hydraulic oil, so if to move a hydraulic motor, this motor would turn intermittently. The practical and commercial solution is to use at least 2 3-stroke engines, and add the flows a way that it is continuous. Another way to do this is by using a hydraulic accumulator and a flow restriction. When exists a flow restriction, the instantaneous flow generated by the piston pump is not able to fully pass through the restriction, and some of the flow enters the accumulator. When the flow stops, the oil leaves the accumulator and the result is a continuous flow that allows to move hydraulic motors and wheels in vehicles. The hydraulic transmission that transforms the energy of the explosions into the spinning movement of the wheel is the most efficient way to do it. Note that there are no mechanical parts in this transmission. This engine delivers more energy per unit of fuel, because less energy is used to move itself. Please note, we eliminate the crankshaft, the transmission with belts and chains, the gearbox, the bearings, and the bushings. This engine is not only efficient, it is more simpler and has fewer components. This engine works with tricks. As the motor stops in each oscillation, if to be used in a vehicle, then the motor could stop the piston upon a computer detecting that the wheels have stopped. As long as the wheels do not need to move, the piston does not need to be moved, and as long as we have compression pressure, the engine can stop injection and ignition. The engine piston stops at a traffic light or in a traffic jam. If the stopping time is too long and the computer detects that the compression pressure has dropped a lot, the engine explodes, the piston pump oscillates, and it's stopped again and wait. At a traffic light, this engine does not pollute, emit noise, or waste fuel. In these respects it might be compared to an electric vehicle. Another trick. The hydraulic motors that move the wheels also serve as brakes. All of the braking accessories used nowadays in a conventional vehicle, they are unnecessary. Another trick. Apart from braking, hydraulic motors act as pumps and fill the hydraulic accumulator just like the piston pump does. This means that, when braking, the wheel replaces the motor. In a traffic jam, a vehicle starts and stops. In each start, the energy stored in the previous stop is used. This is regenerative braking taken to the extreme. Another trick, this engine can use water injection. When practical, we can inject fuel once and water once. Obviously the power will not be the same when injecting water rather than fuel, but since we are taking advantage of residual heat, everything is a gain and the engine's performance will increase. This 3-stroke engine is the most efficient and simple engine ever designed. Now it has to be built.